Okay. Hello, this is the 12 p.m. Zoom meeting for Math 1401, February 1st today. So appreciate, we got a few people who've come out. I guess I'll ask if they've got any questions before I explain what we're going to do today. Looks like we've got three people here. Y'all have any questions today?
Not yet.
Okay. Can't, maybe my volume's down. Couldn't quite hear that. I think I heard a not yet. Let me turn my volume up and we'll try one more time. Does anybody out there have any questions or want to say anything?
Yeah, I was just wondering, when will we get our results for our test?
Plan on releasing them on Thursday.
Thank you.
Yep. Any other questions? Okay, well, I'll explain what we're going to do. Today is probably going to be a very long session, and you don't feel obligated to hang around for the whole thing if you don't want to. We're going to cover section 3.1, section 3.2. There's a lot of material in these two sections. It probably will take at least an hour, could be an hour and a half. I don't think it'll go over an hour and a half. So don't feel obligated to hang around. I'm just going to cover all the material here and in one recorded Zoom session and post it. When you're looking at this, because it's so much material, you probably don't want to watch this in just one session. You might want to, watch a section of it and then go and try to work some of the problems, then come back, watch more of it, and etc. I wouldn't try to absorb all this in one session. The very beginnings of it should be pretty familiar. 3.1, mean, median, and mode. I hope it's familiar. I found the problems on MyLab Statistics much better actually than the problems in the book. So what I decided to do is I can show you the assignment. I mailed it out last night. I cut the book practice problems down pretty low. In fact, I figured out how to hopefully go between my camera and the MyLab Statistics pretty quickly. I'm always learning new tricks. Figured that out this morning. In any case, I cut the practice problems down a lot, and they're just about the basics of mean, median, and mode, and getting range, standard deviation, and etc. in 3.2. I'm going to base the practice problems on Friday off these problems and off problems on MyLab Statistics, but I'm going to spend most of my time today on the problems on MyLab Statistics because it's pretty quirky and you got to understand a little bit of the lingo. So, and there's a lot of problems. So I cut this down a lot. And I think I've got 32 problems here under the MyLab Statistics. But if you'll hang with me on the and learn how to use the calculator, which I'm about to show you, I don't think you'll find it overwhelming. Okay, so what happened is I went to section 3.1, and when I was looking through the problems yesterday, I don't know, it just completely out of order. You do them in the order that are on the screen, and I think you're going to have real problems. So I highly recommend that you do the problems in this order. And so I've kind of labeled them 1, 2, 3, 4, and 5 under the headings that they have. So you're going to find compute the population mean or sample mean from raw data further down the page. I can go back and show you that. Let me get back to section 3.2. I'm sorry, 3.1. Okay, so yeah, if you start with examine skewness and explain what it means to be resilient, you're going to be totally confused as far as I can tell. You'll have no clue what the heck they're talking about. So I'm trying to get you to start down with compute the population or sample mean from raw data. This is pretty straightforward, and we're going to start with that. Then we're going to go to median of raw data. That's further down. Let's see. There's just one problem under median of raw data, and I've labeled the exact problems in the assignment to do. And you can see my green checks. I've worked some of these to make sure that they're good. And then let's see, you can see the headings. So I'll get back to my camera. You can see the exact problems. Under problems involving the mode of raw data, there was just 2 of them. It's pretty straightforward. Under determine the arithmetic mean, median, and mode, those are pretty straightforward. And then finally, this is the very first section they give you. You'll finally be ready for skewness and explain what it means to be resistant. I'll explain all that. And that's the kind of the 5th section to finish 3.1. We're going to go through all this here in just a minute, but let me pause and make sure. Are y'all seeing these screens? I think you are.
I'm just seeing the camera. I'm not seeing it on the MyLab statistics.
Oh, you're not? That really stinks. Oh, rats. I was hoping you were. So you're seeing the camera, but if I go back to MyLab statistics, you're not, I'm on MyLab statistics on my screen and you're not seeing that.
Correct. Yeah, I'm just still seeing the sheet of paper on the camera.
Oh, that's a shame. Okay, well, I may have to stop the share and go back and forth. I was switching back and forth here and I was hoping it would do that for y'all, but it obviously doesn't. So let me go back to the stop the share, go back to MyLab statistics and show you what I'm talking about. Can you see the MyLab statistics now?
Yes, sir.
Okay. So I've labeled all these labels, these headings here, and what I'm trying to do is get you to do this first one they've given you last. Because otherwise I charged into this and I'm going, whoa, this is at the end of the section, not the beginning. The beginning of the section where you should start is like down here, population mean or sample mean, and then you should go to median. There's only one problem there, and then mode, and then finally arithmetic mean, median, and mode, and then do this last. And I've labeled the exact problems on the assignment. You don't have to do them all. Okay, is that as clear as Lake Lanier?
Yes, sir.
Okay, let me just jump to 3.2. 3.2 is a pretty good order that they've given you here. Let me jump to 3.2. Let's see, all chapters. So on 3.2, measures of dispersion, again, on the assignment, I have picked out the problems here. I guess I'll switch back to the camera in a minute. And then empirical rule, yeah, we'll explain that today. And probably by the end of the hour and a half will be the Chebyshev's inequality. So yeah, I don't feel obligated to hang around if you can't hang around for the whole thing. I'm going to try to explain the whole thing in one session. And like you say, I'd watch a little bit, then try some problems, watch a little bit, try some problems. It's a lot of stuff. Questions about this?
I think I've got it so far.
Okay, let me switch back to 3.1. And we will show you the first one was 3.1.7. Okay, again, that's down the page. First one on the assignment is 3.1.7. This is really simple, but there's a lot of quirks to it. Okay, here's the first one I've given you on my paper assignment. It says find the population mean or sample mean as indicated. All right, let me switch back to the camera. I'll rewrite this down. Let's see while I'm here. Find population mean, sample mean. If they're calling it a sample. They give you an answer A, an answer B, and they give you this X bar symbol and this little U symbol. Okay, now I'm going to switch to my camera. Oh, my camera's off. Okay, so I'll have to go back, stop the share. Or let's see, stop the share, new share. Okay, are y'all back to the camera?
Yes, sir.
Okay. So let me just go ahead and charge in with what everybody know what a mean is? Mean is an average. You may know it better as an average. Everybody know how to take an average of a set of numbers?
Yes, sir.
Okay. So we'll call it method 1. We'll call it by hand. Okay. With a mean, you add up the numbers, divide by the number of numbers. All right, the quirk to this is, in statistics, this symbol right here is read X bar, and it is sample mean. It is sample mean. This U symbol is population mean. Okay, they're going to be exactly the same number. You do exactly the same things to get both of them. So method 1 by hand, they're calling this a sample. I would take 22, add 16, add 5, add 8, add 14, and divide by 5. I can cover up or show both. 22, add 16, add 8, add 14, 65. It should come out, divide by 5. 13. Okay, if that's the, anybody want to see me go back and enter that? So I can get my pat on the back from MyLab Statistics, or do we all believe?
We're good.
Okay. If they only give you a small number of numbers, and the numbers are pretty straightforward, small whole numbers, this is the easiest, quickest, fastest way to do it. But very quickly on, the numbers are going to get a lot more complicated. There's going to get more of them. And so we're going to use a method 2. In fact, since I'm out of page, I'll go ahead and do the method 2, stat mode on calculator. So what I do is enter these numbers in statistics mode. The stat button is almost dead center. So I hit it. You want to enter your numbers under the edit button. It comes right up on that, so you can hit enter. More than likely, there is going to be numbers from old problems in. Now, if you're brand new with the calculator, it may be blank, but I'm going to assume very quickly you're going to have old numbers in that you won't want. And an easy way to get them is, or to get rid of them, is to highlight the very top and press clear and then down right above it, down. And you can see the whole column just flushed. It's ready for new numbers. Does anybody want an instant replay? I'll just punch in some random crap from old problem, and I want to clear the whole thing. You clear it. This works for every column. You highlight the top, clear, and down arrow. And it's supposed to not. Well, clear, down. It worked once. My top isn't highlighted. Somehow I got down the page. My apologies. The top is highlighted, clear, down. There you go. The top has to be highlighted. All right, so I'll write these directions down. You hit Stat, you hit Enter, that's on Edit. All right, then you can clear the column. You may not have to clear the column. It comes up blank, you don't have to clear the column. Highlight, top, clear, and down. Now you enter your numbers. In any order, it doesn't matter the order. And I forgot my numbers are on the previous page. Anybody want to call them out to me? 22, 16, 5, 8, and 14, if I can remember that. 22, 16, 5, I hit 8, then 5, and 14. Again, the order doesn't matter. Enter numbers. Then you want to go back to Stat. Over to Calc. Hit Enter on number 1. That is 1 dash variable statistic stats. Comes right up on it, so you can just hit Enter on it. And then Enter again. It's going to give you all kinds of statistics, and we'll show you what, as we go through the things, what you can read off of this. Very basic thing, notice that X bar, 13. Okay, again, that was probably a lot longer than just adding them up, divided by 5. But trust me, by section 3.2 in about probably 20 minutes, we're going to be showing you how to read a lot of stuff off of this that will save you a ton of time. So let me pause for station identification. Does anybody want to ask about anything? See an instant replay?
So the population mean will always be the same as the sample?
The number will. That's what's confusing. On the MyLab, this symbol is population mean. This symbol is sample mean. So on this problem that I just worked, they told me it was a sample. Notice the calculator calls it X bar, and it matched X bar on MyLab. But if MyLab calls the set of numbers a population, you're going to get it from the same spot on the calculator, but you're going to enter it in the box with this. I know that is very confusing, and I'm going through it. It doesn't bother me because I've seen this for 20 years, but I'm going through it last night. I'm going, that's going to confuse the heck out of those people. So I'm trying to very slowly explain this. The calculator uses X bar for both sample and population mean.
So it just comes down to like the wording of the question.
Exactly. Pay attention to the wording, whether they've called it a sample or a population. If they've called it a sample, everything will match. X bar in the calculator, you'll enter it in X bar on the screen. But if they've called it a population, the calculator will call it X bar, but you will enter it under this symbol in MyLab. You get multiple entries. So, if you get confused and enter it wrong and it marks you wrong, that's what's going on. And you just enter it again and, until you get it right. And then you report, hey, I got it right.
Thank you.
Okay. Any other questions? All right, let's go on with median and mode. By the way, the calculator is very repetitive. So you'll wind up doing it over and over, the same keys over and over and over, just reading different stuff off of it. Let's go on to median. There's no great symbol for this. Sometimes you'll see just an M. On the calculator, it uses MED. It is the middle number. When sorted to greatest. On MyLab, they only gave you one problem. 3.1.12. Anybody want to see me go back to it and show you that exact one? Or you think you can figure it out if I do a quick example here?
You can just do a quick example.
Okay. I'll just make up some numbers. We'll call this data set 1. Notice there are 1, 2, 3, 4, 5 numbers. This is an odd number of data. And notice I gave it sorted least to greatest. That would make the number in the middle, I'll call it MED, the median 25. The important thing to realize about the median is that there's the same, it's the spot in the data with the same number of numbers above the median as below. Meaning, look, there's 2 above, 2 below. All right, but then, of course, there's an even case. I'll put one more number in the data. 25, 27, 29, and 31. All right, do you see there's 2 in the middle? With an even number of data, there's 2 in the middle. So what you do is you take the mean of these numbers or average them. Take mean. So your median would be 25 plus 27, and you divide by 2. Can you tell that's going to come out 26? So 26, and notice that gives you 3 above, 3 below. Anybody want to see me? Let's show you where the calculator would give this to you. I'll do the even case. So I'll punch this a little quicker. Stat, edit, highlight the L1, clear and down. 21, 23, 25, 27, 29, 31. If I'm going too fast. Do I need to repeat that?
I got it.
Okay. Then to stat, calc, one variable stats, enter, and you notice there's nothing here that says MED. We're going to use some of this stuff, but coming attractions, nothing here says MED. If they'd asked for the mean, it's 26, but they didn't. Oh no, where's my median? Hit the down arrow and you'll get more stuff. Aha, MED. There it is, 26. You can think of this screen as having 2 pages. So the median appears on the second page. Questions about that? If you're wondering where this stuff comes up in the real world, it comes up everywhere. Have you ever, just really quick, try not to make this too long, ever heard a statistic like the median age for healthcare expenses is 75? Do you understand what that means in plain English? I've read this in articles. Do you need an explanation of that in plain English? Nobody's talking to me. Does everybody understand? You've got to be able to interpret that, understand what that means. Do you understand what that means? Is that completely clear, or do you need a quick, plain English?
Could you repeat it? My audio cut out for a sec.
Okay, sure thing. I've read in statistics, I'm caring for an elderly parent, and I've read statistics like the median age for people for their healthcare expenses is 75. And I'm just trying to ask if you understand what that means in plain English. Or do you need a plain English explanation? Can't get a response.
I think I get it, but if you want to go ahead and explain it, you can.
Okay, it just means take a timeline of your life and then take 75. It's just saying that a half of your expenses, this is birth, a half of your expenses for your entire life from birth, you'll hit a half of your expenses from your entire life up to age 75. And then from age 75 and on, you'll hit the other half. Which means, life expectancies are, like 76, 77, 78 anyway. It kind of shows you how expensive it can be when you get older to care for the health of older people. It's so expensive from 75 on, it takes half your expenses equal to what it took from birth to 75 up. Now, again, remember our quotation, lies, damn lies, and statistics. But in caring for my elderly mother, I actually believe this. Okay, are we ready for the mode?
Yes, sir.
The mode. Most frequent number or data. Okay, I'll give a few examples. On my lab, they gave two of them, 3.1.6 and 3.1.29. Let's see, data set 1, 17, 19, 21, 23. Okay, can you tell nothing is more frequent than anything else? This would have no mode. Or I think I worked one of these in my lab. They'll say it mode does not exist. And by the way, you don't do a mode on the calculator. I've never seen a calculator do the mode. This is not on the calculator. You can't punch the data in and read off the mode. All right, so let's say I'd use 17, 17 and 19, 21, and 23. Can you tell here your mode? And again, there's no great symbol for it. Mode is 17. All right, so what if I do 2 17s, 2 19s, 21, and 23? Now I've got two modes. Can you tell our modes are 17 and 19? Are we going too fast?
No, that makes sense.
Okay. So finally, what if you list them all twice? Can you tell you are basically back to this case? They're all listed the same number of times. Nothing is more frequent than anything else. You're back to no mode. Questions about that?
So if there was one where it was 2 17s, 2 19s, and 2 21s, that would still have three modes, right? It's only if there's all of them are the same number that there's no mode.
Exactly. So yeah, if I took out that last 23, yeah, we would say the mode, you got three modes. They call it trimodal. 17, 19, and 21 are listed the most frequently. Yeah, but put an extra 23 on, now they're all listed twice, no mode.
Thank you.
All right. My lab also has a section of arithmetic mode, mean, median, and mode. And I really couldn't tell any difference. They're making a big deal about, do something with arithmetic. I kind of worked in the same way and got the same correct answers. So I don't think there's any real point going over that. I think you do the exact same thing if it's an arithmetic, mean, median, or mode. So finally, we're bound to the first section they give you. What does skewness means and what does resistant mean? Okay, like I said, I wouldn't start there. Well, you can't, after I explain it, maybe you can start there. But we're down to explaining that first section. Basically, it's about this question. What is the best representative number for a set of data? The mean or the median? When I'm in class, I use weight data. But I don't know if y'all want to publicly over Zoom tell me what your weight is. So I'm I always ask for light people. So I'm going to just make up some weights, typical weights that I usually get in a class. 110, 105, 115, 112. All right, now I'm going to have a data set 2, and I'm going to put in an outlier. Put in an outlier. So I'll use the same data, 112, and I'll put in me. I go about 300 pounds. That's what makes me high risk for COVID, and that's why I'm sitting here doing this online. I've been on every diet known to man. They all want you to do something strange, like eat right and exercise. I can't do that. Okay, that makes me an idiot, but let's go on. Any questions so far? All right, now that we know how to use the calculator, let's do the mean and median for both data sets. Mean, median. This is no outlier. All right, so I'm going to punch them in. Let's see, 110. Oh, no, got to be in stat mode. Stat, edit, up, clear, and down. Hope this isn't going too fast. 110 plus 105 plus 112. Oh, dang. Okay, one more time. 110, enter. 105, enter. Enter. 112, enter. Stat, calc, one variable stats, enter. My mean is 110.5. Down, median, 111. Did we go too fast?
No, sir.
All right, now I'm going to do the same thing. All I got to do is call the data back, get back into stat, edit, and I got the same data. I'm just going to go to the bottom and stick in my 300. All right, so here's my data set with the outlier. Stat, calc, one variable stats. See, it's very repetitive. Enter. And now my mean, 148.4. Go to the next page. Median's 112. All right, that's just the raw numbers. Now we're going to talk about what they mean. Questions about this?
I don't think I have any questions.
Anybody else have any questions? You see how much work the calculator saves you? Okay, once this is done, the point is the change. What is the change in mean? Versus the change in the median. Okay, the change in the mean is the difference. So you've got 148.4 subtract 110.5. 148.4 subtract 110.5. 37.9 pounds. Change in median, change in median. 112 minus 111. I do that in my head. 1 pound. Can you tell what changed the most?
The mean.
The mean. Can you use this? Can you now tell what's the best representative number? That's, I don't want the pound confused. 1 pound. Maybe I should do it out here. Can you tell, does this demonstrate anything to anybody or only to me? What is the best representative number?
The mean.
Well, look how much the mean changed when we put in a huge outlier. But look how little the median changed. Do you see the four kind of very similar numbers, and then you got the freak, the heavyweight, me. Is 148 a best representative number of this, or is the 112 you think is the better representative of this?
112.
Yeah, probably the 112. We could say this a couple of different ways. First of all, you understand why this is happening. I could write out the numbers and you can tell why this is happening. No outlier. Your mean worked out. Wow, lost the numbers. Okay, 110 plus 105 plus 115 and 112. You're dividing by 4, which worked out 110.5. If you put them in order, 105, 110, 115, no, it was 112, then 112, then 115. So you can tell your median's 111. Middle between 110 and 112. See 2 numbers above, 2 numbers below. Outlier, you can see, if you see the numbers written out, you can see what happens. Plus 105, plus 115, plus 300, and you're dividing by 5. See, 4 and 5 doesn't change much. That's not a lot of difference. What's the huge difference? You're adding this huge number on the top of this. That's what changes it the most. And that made the mean go to, was it 148.4? Yeah, 148.4, while the median, you see why the median doesn't change much? It went from the average of 2 of these numbers. See, if I add the 300 on here, now there's 5, and the middle number is 112. So it went from the average of 2 of the numbers to one of the direct numbers, just 1 pound difference. So we can say this 2 different ways. The mean, this is called distorting the mean. The mean can be distorted by outliers. The median is resistant. That's the key word that my lab statistics is. The median is resistant to outliers. See, this is called being resistant. You just didn't change it much, even though you stuck in a huge number. It's like, there's really resistant to being changed. Whereas the mean, I jacked it up by 37 pounds by adding this huge number on top. Is this as clear as Lake Lanier?
Yes, sir.
Okay. Do you think you all can handle a few of those MyLab problems on your own now, or do you want me to go back and try a few examples for you?
I think I'm good. I don't know about everybody else though.
Anybody else want to see any examples from MyLab? Okay, so what this does is this gives away to determine shape without drawing histograms. They're going to ask about this in MyLab. Symmetric, normal, or Bell. It's all the same thing. What we're going to do is draw you pictures, and remember the vertical is frequency or relative frequency, either one. And we are going to have you put these three words on the diagram. Mean, median, and mode. There's going to be a blank for one of them right here at the center. Can you tell which word would directly go at the center?
Median?
Well, we have a vote for median, okay, but most directly, see, you're at the point, at the peak, you're at the point of highest frequency. Or most frequent, that's the word we use with mode, most frequent. So doesn't that match the definition most directly of the mode? Mode is at the peak. Now, you're right, you mentioned median. If this is truly symmetric, half your numbers are above, half your numbers are below, which makes it the definition of the median. And does it not all make sense that if truly half are above and half are below, that this will average out to the same place? So this is also the mean. All three are in the center. Your mean equals your median equals your mode on a symmetric bell curve. Is everyone convinced? Any questions about that?
I think I'm good.
Okay. But remember, this never occurs in the real world. There's nearly always an outlying number, a fat guy. Or maybe there's a thin guy, who knows? So we're going to put in a skewing number. Large one. Skew right. This will spread out the words. Again, the words are mean, median, and mode. Now we're going to have 3 blanks. I'll call it a blank at the peak, lined up with the peak, a blank in the middle, and a blank toward the tail. Anyone want to guess which word stays at the peak?
Mode.
Very good. It's still the mode, the most frequency. Now, mode stays at the peak. Based on our example, which word changed the most?
The mean.
The mean changed the most. So it will go in the tail, the right tail on a skew right. So that just leaves, one blank left. Which word changed the least? The
Median.
So this is your definition of a skew right. Your mean is greater than a median. Or let's say if your mean is greater than your median, your shape is skewed right. They'll ask about this in my lab. Your mean is greater than your median, you're skewed right. Questions about this? All right, so let's put in a third case, small outlier. Skew left. Again, I'll line them up alphabetical this way: A, B, B in the middle, and then at the peak. I meant that to be at the peak. C. Which word would stay at the peak?
Mode.
Mode. Which word would change the most?
Mean.
Mean. See, it goes to the tail. Median stays in the middle. It's resistant to change. Do I need to write this down? Mode is at the peak, mean is in the tail, median is in the middle. Anybody want me to write that down?
Yes, please.
Okay. Mode is at the peak, mean in the tail, median is in the middle. Just the direction changes. If it's skew left, the mean's in the left tail. So if your mean is less than your median, your shape is skewed left. That pretty much finishes this, and they're going to ask about it in the MyLab in that first section. Examine skewness, explain what it means to be resistant. And I skipped more than a few of them and looked through them and thought these were pretty reasonable to do. Don't thank me all at once for skipping a few of them. That pretty much finishes 3.1, and I was going to go ahead and do 3.2 under this meeting. Don't feel obligated to hang around. It took 55 minutes to fully explain 3.1. I think 3.2 will go a little quicker because I won't have to explain all about the calculator. the calculator stuff, entering the data, that'll all be the same. I'll just point out the stuff we're going to read off of it in 3.2. But anybody have any questions before I charge into 3.2? And like I say, I fully expect this to take till at least 1:30. So don't feel obligated to hang around. You can watch the rest of the video at your leisure when I upload it to YouTube. Anybody have any questions before I charge ahead?
I don't think so.
Okay. Well, I'll show you the assignment for 3.2. It's there under my plan, and the headings, like say, I would work the problems in this order, and this is the order that's on the screen. That seemed pretty straightforward to me. So it's under section 3.2 called Measures of Dispersion. And I picked these problems out of range, standard deviation, and variance. And they got a little tricky on some of these. Maybe I should work one of these problems for you. I'll show you what they mean. And then this is where it gets a little more involved. Called the empirical rule and called Chebyshev's inequality. All right, I counted up 32 problems, and just email me the percent of these that you get correct between both these sections. Okay, it's called Measures of Dispersion. Another word for dispersion is variability. In other words, how wide spread are the numbers? Are they very wide, or are they very uniform, very wide, or close together, like that weight data without me? How do you measure this? Okay, I know you're dying to know, and you may have seen some of this before if you took some statistics in high school. First measure, the range. And you take the max, which is the biggest number, minus the min, the smallest number in the data. Let me hug that weight data pretty close for some of this. We'll just mine that weight data for all we can use it for. I think it was a 110, a 112, a 105, 115, and I think me at 300. Maybe I better double check that. One 110, 105, 115, 112, and 300. Yeah, I think I got it. All right, so if I use that data and figure the range, well, I'm biggest at 300 and someone in there was 105. So looks like your range would be, probably could do it in my head, but 195. Uh-oh, I may have fallen out here. Better stop. All right, I may have broken up there. Am I back? Can y'all hear me now? Nobody talking to me. Can anybody hear me?
I can hear you now.
Okay, you can hear me now. Great. So does this range make perfect sense?
Yes, sir.
Okay. You cannot read the direct range off your calculator. I don't know if I still got this data in. Let me see if I do. I do. All right, so stat, calc, Bureau stats. Okay, there is no line for range. it will on the second page, this min X is the smallest, so that's your 105. And your max X down here at the bottom, that's your 300. It tells you individually, in case you can't spot the biggest number and the smallest number, but for doggone it, it will not subtract them for you. Will not subtract them. Some people don't subtract, they just think the range is, well, there's the range, you know, it's between 300 and 100. That's not what we want. We want the single number when you subtract the biggest number minus the smallest number. And the calculator won't do that for you. You'd think for $100 it would, but it won't. Go figure. All right. Number 2. This is such a gross measure, it's completely useless. What is useful? What is useful is the standard deviation. And what we do, we create statistical number line. So just like your standard number line you're used to in algebra, except the center of a standard number line is 0, the center of a statistical number line is the mean. This is the center, mean. And on a normal number line, you have tick marks, 1, 2, 3, positive right, -1, -2, -3 left. Well, we're going to have the same thing, except we're going to label them 1S, 2S, 3S. These are S's. You'll also see this symbol used. We'll explain the difference between them in a minute here, because MyLab will use both of these symbols. This is read 1 standard deviation above the mean. 2 standard deviations above the mean. I won't write it down. 3 standard deviations above the mean. They don't go beyond that. We'll explain why in a minute. Well, if you can be above the mean, you can be below the mean. S, and the same symbol. 1 standard deviation below the mean. That's an S, and then -2, this. And then -3. Okay, if I take a data set and all numbers lie from -1 to 1, can you tell that would be a tight distribution? Very similar numbers. But if I take another one and they lie from 3 below to 3 above, the numbers vary. This is data set B. This is data set A. Data set B varies from 3 below to 3 above. Can you tell this is very wide? Let's pause for station identification. Have we lost anybody?
I think I got it.
Okay, this is the other way we identify outliers. Any data value beyond 3 is a definite outlier in either direction. You got a data value, it's beyond 3 standard deviations from the mean. It is way different from anything else. Definite outlier, either an outlier above or an outlier below. Okay, let's actually create the statistical number line for this. And I'm not going to do it by hand. In the ordinary class, I do it by hand, but I'm not going to bore you with that today. We'll use the calculator. So I got 110, 112, 115, I had a 105 and a 300. We're going to create a statistical number line. All right, the mean, was it 148.4? I think I got the data still in here. The mean was 148.4. That would go at the center. I'm trying to create a statistical number line. Okay. By the way, maybe we should explain what a standard deviation is before I show you the numbers for this. A standard deviation the average distance each data value from the mean. Maybe I'll very quickly explain how they're going to get it. The mean here, 148.4. If I want to establish the average distance of each of these numbers from 148.4, and by the way, they're going to call this S squared. This is called variance. Then I take each data value, I'll start with the 110, and I subtract the 148.4. Okay, that'll be its distance from 148.4, but notice how it's negative. So I square it to turn it positive, and I do the same thing with the next one. I do it with all of them. You see how bothersome this can be, doing this by hand? Plus 105 minus 148.4. Notice how all these are called individually deviations. See how all the numbers are below that mean? They would all give me negative deviations, and then there's me. Notice I have a positive difference. All those negative differences with my positive difference turns out balance out would give me 0. So that's why they square them. And I'm going to divide by, how many numbers were there? 5 numbers. Divide by 5. That's what creates the average. I don't know if you want to watch me punch this or not. Actually, it turns out I should be using this symbol. This would be called population variance when they divide by the direct number of numbers. Okay, you got the patience to watch me punch this out? Probably not, right? You want to just jump right to the answer? You can punch it out if you want, if you don't believe. You want me to just jump right to the answer?
Yes, please.
Okay, the answer see that symbol there? For some reason, the calculator sticks an X by it. I have no idea why. And notice the power on it is 1. Turns out it's 75.87. If I followed this screen down, I would get variance, and it turns out it would work out the square of 75.87. I'll just do that real quick. 75.87 squared works out 56.2569. Could be some round off error in it. If I punch this out, I would get this, take a square root, and I get this. This is called population variance. This is called population standard deviation. In other words, each of these data values are 75.87 pounds on average from the mean, meaning their differences from the mean average out to 75.87 pounds. Do you see where to read this? Population standard deviation. So what's the SX number? By the way, let me show you the scheme. In effect, here's the formula. They're taking each data value, they call it an XI, data value minus mean, square it, and dividing by the number of numbers. And then to get the standard deviation, this is population variance. They're taking the square root of this. Population standard deviation. If they want to sample, they do S squared, and it turns out they divide by one less than the number of numbers. You're taking XI minus mean squared. They put this, I forgot that symbol off this. They use this symbol, this means add. I'll show that. Okay. And you divide by one less than the number of numbers. That's called sample variance. When it's squared, and when they take a square root of it, it's called sample standard deviation. Square root of S squared, sample. I'm probably making this a lot more, because probably reading a lot more complicated, and it's a lot of information to throw at you. And notice how it's bigger. For this data, your SX would be 84.825. Anybody want to ask anything about this before we go on?
What does the SX stand for?
The what now?
What does the SX stand for?
Just a weird TI notation. I think they're using it to stand for the X values of the data, but it's not used in my lab. You can just ignore it.
Okay, thank you.
No. To me, it just confuses the heck out of everything, having all these different symbols for the same thing. But I didn't make the calculator and I didn't write my lab, so I'm trying to explain what they're doing to try to keep the confusion to a minimum. Okay. Now that we know what the numbers are, let me go back and redo the statistical number line. So here's our number line. We've got our mean, it's 148.4. Our different data was 110, 112, 105, 115, and 300. Gave us our mean of 148.5, and we'll use this population standard deviation. Didn't it come out 75.87? Gold star. Remember this, I'll just use this symbol. The symbols can be used kind of interchangeably. They are different numbers, again, because they're dividing by something slightly different up here. But it's the same concept for both. This means we're taking 1 times 75.87. Now, do you understand that is not the number that goes here? It can't be. If I have 75.87, do number lines go from 148 down to 75?
No.
No, they don't. So gold star, if you can tell me the number that does go here. Are you ready for your gold star?
Can you give me a hint, like as to what to do to get it?
Well, if it's above the mean, wouldn't you take the mean and add this?
Oh, you would do the thing where you subtract it and then you square it to make it positive.
Well, okay, now that was the scheme to come up with this number. We're beyond that.
Okay.
We followed that scheme and established that the average numbers or value of difference of these from the mean was this. And now I'm laying this out on the number line. And so if this is
Would you add it to it because that's the deviation from the middle?
bingo, exactly. This number is going to be 148.4, add 75.87. $224.27. What if I want the number 2 up? There's 2 ways to do it. Since I know the 224.27 and I want one more, this is twice times 75.87. But again, that is not the number that goes here. Can you see the 2 ways? I could just take 224.27 and do what?
You could just add the 75.87 to it, or you could multiply it times 2.
And then add the 148.4.
Right.
Yeah, you do it either way. So yeah, you could go 148. In fact, that's the way I'm going to choose to do it. Add twice 75.87. So all I got to do is call it back. If you know about your calculator, second edit, you can call it back. And I'll just multiply that standard deviation by 2. 300.14. What if I want the number 3 up? All I got to do is change the 2A.
To a 3.
To a 3. Call it back. Change the 2 to a 3. In other words, somebody who weighs 376.01 pounds is 3 standard deviations above our mean. I'm basically at 300. I'm basically 2 standard deviations above our mean. Somebody weighing 75 pounds is 1 standard deviation. Not 70. 224 pounds is 1 standard deviation above our mean. Well, if I filled in the number line this way above the mean, do you see all I got to do, what I got to do to fill in the back half?
Just make it negative.
Just make the plus, change the plus to a minus. Since I've already got this one in, I'll do it from outside in. So minus 3 standard deviations, I call it back. Okay, call it back, second enter, run the cursor over, and I'm at negative 79.21. Don't worry that that's not physical. Nobody obviously weighs negative pounds. That's just the way the numbers are working out. Minus 2 standard deviations, call it back, and I'll change the 3 to a 2. Or you can punch the whole thing again if you want. Negative 3.34. All right, still not physical, but that's all right. That's just the way the numbers are working out. And how about somebody at 1 standard deviation below? I'll call it back and I'll just delete the times 2. They're at 72.53. Questions about this?
I don't think so. I think I'll just get more comfortable with it the more I practice it.
Okay. I kind of overestimated how much material this was. I've got basically the first section of this explained of 3.2 on the MyLab, and I really need to do the last two sections, but I had an appointment with my son at 2 o'clock. And if I actually do it, it's going to run, yeah. I tell you what, if you don't mind, I appreciate you hanging with me this whole time. I'm going to end this video here, and I'm going to finish it up from this point on with a separate video. I'll make it tonight and distribute it.
Okay, sounds good.
Okay, I appreciate you hanging with me. It was a lot of stuff to throw at you. I hope it made sense, and we'll definitely help
It
you out.
did, yeah.
Definitely help you out with the 2 more sessions on Thursday if you need them.
Okay, great. Thank you so much.
Thank you very much. I appreciate it.
All right, have a great day.
Same to you.